this lecture on chapter 3, first order systems, we will see a problem related to the dynamics. This question is from previous year question paper of GATE Chemical Engineering. The question is this. This is from Chemical Engineering 1995 paper, question number 25. So it reads, when a thermometer at 30 degrees centigrade is placed in a water bath at 90 degrees centigrade, the initial rate of rise in thermometer temperature is found to be 2 degrees Celsius per second. What is the time constant of thermometer, assuming it is a first order device with a unity steady state gain? What will the thermometer read after 1 minute? So there are two questions. One is time constant, second is thermometer reading after 1 minute. So it is about thermometer. Thermometer, we know it is a first order system with a unit steady state gain. It is clearly mentioned here. Assume it to be a first order device with a unit steady state gain. So it is a thermometer. The transfer function is first order k by tau s plus 1 with a unit steady state gain k equal to 1. Now what sort of input is given? Thermometer is initially at 30. It is placed in a water bath at 90. So the surrounding temperature changes from 30 to 90 degrees. So it is a step input. Sudden change from 30 to 90. Step input of magnitude, how much? What is increase from 30 to 90? 60 degrees. 90 minus 30, 60 degrees. So it is a step input of magnitude 60 degrees. So this is what is given. And what is also given is the initial rate of rise in thermometer temperature. So when we have discussed the features of step response of first order systems, we have discussed about this, the initial rate of rise of thermometer. So when you give a step input, the rate of response will be the highest at t equal to 0. The initial rate of rise will be the highest of all. So what will be the initial rate of rise? What is the equation for that? We have discussed this. We can discuss the initial rate of rise in when we discuss the sinusoidal response, features of step response of first order systems. That was in PC38. In PC38 of my video series lecture, we have discussed this, and this figure shows the step response. And if you draw the tangent at 0, the tangent represents the rate of initial rate of rise. The tangent at 0 represents the initial rate of rise. So what is the slope of the tangent? As you can see from this, so y by mk versus t by tau. So if I plotted simply y versus, if this is not y by mk, if it is y and x-axis is simply t, and then what will be this? This will be tau, right? This will be tau. If you plot t versus x, if the x-axis is t, this value will be tau. Instead of 1, it will be tau, and here it will be mk. So what will be the slope of the tangent? The initial rate of rise will be equal to the slope of the tangent at t equal to 0, right? So what will be the slope of this tangent? If you look at the figure, the slope of the tangent will be mk by tau, right? Mk by tau. And it is given that this initial rate of rise is, how much it is given? The initial rate of rise is given as 2 degrees Celsius per second. So mk by tau equal to 2. So tau will be equal to mk by 2. M is how much? 60. K is 1 equal to tau equal to 30 seconds. So the time constant is 30 seconds. So that is the answer for first part. First part is what is the time constant of the thermometer. So that is equal to 30 seconds. So here I got the initial rate of rise from the slope of the tangent from the figure. Alternatively, if you don't want to see the figure, if you don't remember the figure, then you can also get from the equation. What is the step response equation? The step response equation is this, right? So if you want to find the rate of rise means the slope. So what will be the slope of this equation? dy by dt. dy by dt. So dy by dt is what? If you differentiate this, the mk into 1 is constant. If you differentiate this, this will be 1 by tau e power minus t by tau, right? If you want initial rate, we want initial rate. What should I do? I should, that is at t equal to 0. We put t equal to 0 here. What do you get? At t, if you evaluate this at t equal to 0, what will be this? E power minus 0 is 1. So it is going to be mk by tau. So the initial rate of rise is mk by tau. Whether you see by this equation or by this response figure, that will give you initial rate of rise is mk by tau. Initial rate of rise is mk by tau. Same thing here. Initial rate of rise is mk by tau. So from that we got tau is 30 seconds. The next question is, what will the thermometer read after 1 minute? So for that you have to go to the step response equation, same, this equation. So from this equation you can get after 1 minute what is the thermometer reading. So let us substitute here. Let us substitute in the response equation and find out the answer. That is here. This equation, if you take this equation, if we go by this equation, response equation, this is what? Y minus ys equal to m is 60, k is 1, equal to 1 minus after 1 minute. So this is all 30 seconds. So 1 minute is 60 seconds and tau is 30 and ys is how much? Ys initial steady state temperature of the thermometer as well as the surrounding is 30, right? Initial ys as well as xs is 30 here. So ys is 30. So if you substitute and find out y, this is 30, ys is 30. So find y from this, equal to 30 plus 60 into 1 minus e power minus 2. What is the answer? Is going to be, what is the answer? 81.87. So after this answer is this, gives me 81.87 degrees Celsius. So after 1 minute, the thermometer will read 81.87 degrees Celsius. So this is the answer for second part. Simple question. Only thing what is given is something new. What is new here is this initial rate of rise. Initial rate of rise is given. So that is the new thing in this. Something not very difficult. So we understand the concept. Initial rate of rise is shown by this tangent at t equal to 0, or by from this equation you can get it well. So hope you have understood this. If you have any doubts, you can comment on the comment section.